2.5a, implicit differentiation. Okay, so explicit form is what you're used to. For example, let's see, in red, y equals x squared plus 3. This is what you're used to. This is explicit form. It's written out explicitly in terms of x. Y is defined as the function. It could be f of x, it could be y. And then x is the variable that we're deriving in respect to. Implicit form is when this same equation is written out basically in some form of standard form, if you recall standard form from Algebra 1. So the x's and the y's are on both sides of the equation, or together on the same side. Depends on the equation, really. Now this is implicit form. Now these two things are exactly the same. When we derive, we've been deriving explicit form up to this point. And when we derive, y becomes dy dx. And then x squared plus 3 is 2x. Now, if I derive this equation, I will get exactly the same answer. Sometimes, when it's as simple as this equation is written out, you can just make it into explicit form. But other times, and most times, that implicit differentiation is required, because that's what this section is about, you can't actually separate the y or y's from the x's. So you have no choice but to derive as is. So basically, here are the guidelines for deriving a function that looks like this. Just make pretend that this was a lot more difficult than what it looks, and you couldn't actually make it look like the explicit form. All right, so step 1, you're going to differentiate both sides of the equation, but with respect to x. And so if I'm deriving with respect to x, but there's a y there, that is not the variable I am deriving with respect to. So suddenly, I am now forced to take into account the fact that y is not x, and I'm using the chain rule. Step 2, collect all terms involving dy dx on the left side of the equation and move all other terms to the right side of the equation. Step 3, factor dy dx out of the left side of the equation. And then step 4, solve for dy dx. So these don't make sense right now, but hopefully they will. Before we actually start doing implicit differentiation, we're just going to do this, I guess, a beginner's, an implicit. See, the thing is, implicit differentiation is usually an equation, and it equals something. These are not equations, they're just expressions, because they don't equal anything. But it's just a trial run, I suppose. So x cubed. So here I'm deriving with respect to x, because that's what that says. And this is x cubed, and okay, that's no problem, because we've been doing that. So it's 3x squared. Okay, well, what I want you to see is, for part B, we are now going to derive a very similar function. It's y cubed. But I'm still deriving with respect to x, but as you can see, there is no x in the actual function. It's y. So what you do is, you can make pretend that this is u cubed, and then derive that. And you get 3u squared times du. Alright, if u is y, then du would be the derivative of y. Which, if this were x, it would be 1. The derivative of x would just be 1, but it's not x. It's y. And I'm being asked to derive with respect to x, and there's no x here. So I have to compensate for that. So what we do is, we derive the variables that are there, but with respect to x. So if u is y, and du should be 1, but this is like another chain rule, times the derivative of y, which is dy dx. Okay, the derivative of y is dy, but since we're deriving with respect to x, we're going to write dx. Let me fix that because it looks horrible. I don't need the 1, right? It's not really. Okay, let me write this over. dy dx. Okay, so with that said, I come back over here, and this is 3 times u, which is just y squared, right? So 3y squared, 3y squared times du, which was dy dx. This is how you derive implicitly. Whenever it's a variable other than the variable you are deriving with respect to, you're going to have to do some kind of mini chain rule that adds or attaches this, dy dx, in this case because it's y. In the near future, we'll be deriving implicitly with many different variables, and it'll always be in respect to time. So whenever we derive, it'll be, let's say we're working with height. So it's going to be h for height, so it'll be dh dt, because t stands for time. But that's not here yet. All right, let's see, pen next. C. So the derivative of x is 1. The derivative of 3y should be 3 times du. Okay, remember again, y is u, so du should be the derivative of y with respect to x, dy dx. So 1 plus 3 times dy dx. Now this is not all there is to the implicit differentiation, but I'm just trying to begin with how to derive, and then I'll show you that next. All right, d, it's a, what do you call that? A product rule, right? So it's u times v. Okay, so u times v prime. So the derivative of y squared should be 2y dy dx. So u times v prime plus v, which is just y squared, times u prime, which is just 1. And I guess I'll just... So this is now derived implicitly. There would be more steps normally. Okay, so this is just like a little trial run. Example 2, this is what it's actually going to look like. Find dy dx given that x squared plus y squared equals 6 times xy. Okay, so if you look, I have an equal sign. I have x's and y's on both sides. So, to begin, the derivative of x squared is 2x. The derivative of y squared is also 2y, but because I am deriving with respect to x, and y is obviously not x, I have to multiply by the derivative of just y, which is dy, divided by dx, or over dx, because remember, we're deriving with respect to x. All right, equals, oops, and I have 6 times x times y. I'm going to treat the 6 and the x as u, and then y will be v, because I need the product rule. So u times v prime. So y becomes 1 dy dx. I'm not going to write the 1. So u times v prime plus v times u prime, which is just 6. So there you go. So we derived both sides of the equation now. If you look back up the guidelines, it says collect all the terms involving a dy dx on the left side of the equation. So what is actually being multiplied with dy dx? So this term right here has a dy dx, and this term has a dy dx. They're being multiplied. The other two, the 2x and the 6y, and you know what, I'll just rewrite that real quick. That's 6y. Oh, not crayon, pen. 6y. Okay, so what I want to do is I'm going to move. So I would move this over to the other side by subtracting, because it's positive. So that would move it that way. And so now I'll have 2x plus 2y dy dx minus 6x dy dx equals 6y. And then if I look, this is the only term left here, right? That I need to move over to the right side because it does not have a dy dx, right? 6y didn't have a dy dx. So it's still here. So I keep hitting crayon. Now this is going to go that way. And I'm going to subtract 2x to do that. So 2y dy dx equals, or not equals, sorry, minus 6x dy dx equals 6y minus 2x. So eventually you should be able to do a lot of this just in your head. You don't have to write it out. Or not in your head. You know, you think about it and then you just write the next step without having to do every single minor detail on your paper. Okay, so now the objective was to get these on one side of the equation. Step 3 says factor dy dx out of the left side of the equation. Okay, so you're going to factor these two out. No, not creative pen. Okay, so dy dx, right? Factor these out. I have left over 2y minus 6x equals, well, 6y minus 2x. Okay. I factored it out. Step 4 in the guidelines says solve for dy dx. Okay, so what I want to do is I want to get this alone. Right now it's being multiplied with the 2y and the 6x. Remember, I got the 2y from here, the 6x from there. So since this whole thing is being multiplied by dy dx, I'm going to divide. So divide by 2y minus 6. And then whatever I do to one side, I must do to the other. So now, this goes away. I have dy dx all alone. And that's going to equal 6y minus 2x over 2y minus 6x. Now the only thing I see happening here is that these are all multiples of 2. So I could just divide the 2 out of everything. 6 divided by 2 is 3. 2 divided by 2 is just 1. Oh boy, I can't write correctly. 3y minus 1. 2y divided by 2. Oh wait, what did I do? I'm sorry, 2 divided by 2 is 1, but that does leave x behind, so it's 1x. Sorry. Why does this look weird? It doesn't want to write now. Great. I know. Okay. 2 divided by 2 is 1, so that leaves y, and 6 divided by 2 is 3. And there is my answer. Alright, example 3. Find dy dx. Throwing in a little trigonometry. So derive sine of y. So if it helps, pretend it's sine of x. So you get cosine of x, but it's really y. So cosine of y dy dx. So hopefully you're seeing that every time that you derive the variable y, you have to attach the dy dx. That's the chain rule part of it. Okay, the derivative of x is 1. My goal is still to get this by itself. So currently, it's being multiplied with the cosine y. So all I have to do is divide by cosine y. Divide both sides. So there you go. And then maybe, I don't know, if this were multiple choice question, they would write it as, instead of 1 over cosine y, they would probably, maybe, write it as secant of y. Either way, these are both correct. Number 4, same idea. only I see that there's a chain rule. Right, I'm going to treat the 4 as part of the cosine x, so that'll be u, and then sine y will be v. Okay, so, oh, let me write it down. So this is u, and that's v, right? So u times v prime, so derivative of sine y. So that's cosine y dy dx plus v, which is sine of y, times u prime, which is 4 times negative sine x. So negative 4 sine x. And then equals, and then derivative of 1 is 0. Okay. Let's see. We're trying to now look for anything with a dy dx so that we can isolate it. And so this is the only thing. So everything else just gets moved around. All right, I need a pen. Raincoat. So let's see. This part, let me just highlight it, so this stuff is being added, right? So we can subtract it. So 4 cosine x cosine y dy dx. I subtract this stuff to both sides, right? So it equals negative sine y. Oh, there was a negative here, right? So that takes care of that negative. So sine of y times sine of x. Okay, still trying to get this alone. Oh, hold on a second. Still trying to get this alone. So now I would do that by getting rid of the 4 cosine x cosine y. Let's see, highlighter. So this stuff is being multiplied with the dy dx, so to get rid of it, I would divide. So dy dx equals, so on the right side we have sine y times sine x, and then by moving this over, I have to divide. So I get 4 cosine x cosine y. Why do I feel like I forgot to write something down? Oh, I did. Of course. Never a day that I miss. This 4 right here. It was negative 4, right? So I had to move that over with it. Oops. Should go here. Let me add that now. Sorry. So that's 4. Okay, so 4 sine y sine x. So this is 4 sine y sine x. There we go. Okay, the 4's do, what's the word, cancel out. And so I have dy dx. Now, you can leave it as sine y over sine x divided by cosine x over cosine y. Ooh, actually, you know what? Let me, sorry, if you wrote this down, it's not a big deal. See the cosine x, cosine y, what if I decided to put the cosine y under the sine y and the cosine x over the sine x? When those 4's cancel out, I can leave it as sine y times sine x over cosine y times cosine x. Or, let's see, highlight, or I can, let's do green. Sine y over cosine y is tangent y. And sine x over cosine x is tangent x. I mean, I guess it depends. Like, this would be a kind of multiple choice question, right? So, oh, I was going to write it again. Okay, so tangent of y times tangent of x. It does look simplified, a little more simplified anyway. So there you go. Okie doke. Next. Example 4, find the slope of a circle, x squared plus y squared equals 25, at the point 3, negative 4. Okay, so implicit differentiation. So 2x plus 2y dy dx equals 0. Gotta love those whole numbers. Those are not whole numbers, they're constant numbers. Just numbers become 0. Okay, gotta isolate the dy dx. So 2y dy dx equals negative 2x, right? Because I'm subtracting 2x, so I can move it to the right side of the equation. Still trying to isolate the dy dx. So I'm going to divide both sides by 2y. So negative 2x divided by 2y. The negative 2 and the 2 cancel each other out. So I have dy dx equals negative x over y. If I want to find the slope, right, I derive, which I did, and specifically they want me to find it at this x and this y. So dy dx equals negative 3 divided by negative 4. So 3/4. And there you go. Alright, homework. Answer the practice problems.